Welcome to Spring LIB.
We're asked to show that of all the isosceles triangles with a given perimeter, the one with the greatest area is equilateral. So to understand this problem, we know that an isosceles triangle can be drawn sort of like this. So we have two sides, S with the same length, and then a base with a different length, or maybe the same length, and then a height, H, from the base to the top. Now we can express the height h in terms of S and B with the Pythagorean theorem. So we have the height S is equal to the square root of the hypotenuse, S squared minus B over 2 squared. Now the area of the whole triangle is half the base times the height. And then we want to write area in terms of B. Sorry, before we even do this, this is 1/2 B times the square root of S squared minus, this is B squared over 4. And we'll let P be the given perimeter, so P is actually a constant. Well, the perimeter is given by 2S plus B. And so we can write B as a function, or S as a function of P and B. So that S is equal to P minus B over 2. And so plugging this in, we get that the area as a function of B strictly is 1/2 B times the square root of P minus B squared over 4 minus B squared over 4. And this reduces eventually to 1/4 B times the square root of P squared minus 2PB. Now, in order to maximize the area, we'll find the derivative A prime of B. Now, on the one hand, you could take the derivative of this expression. Alternatively, we know that the area is also maximized when the area squared, which I'll call F, is maximized too. So F of B is B squared over 16 times P squared minus 2PB, which is P squared over 16 times B squared minus 2P over 16, which is P over 8. B cubed. So the derivative F prime of B, this is P squared over 8B minus 3P over 8B squared. We want to find when this is equal to 0. Well, we can factor this as, factor out a P over 8B times P minus 3B equals 0. And so we get that B equals 0, or B equals P over 3. Now, very clearly, B equals 0 is not a reasonable answer. It's not going to be maximum area. So we only have the critical value of B equals P over 3. Now, looking back at our area function, we see that or even just looking at f prime of b, f prime of b is going to be greater than 0 for b less than p over 3, and that f prime of b is less than 0 for b greater than p over 3. You can see this from our factorization of f prime of b. Therefore, it follows that f has a maximum value at b equals p over 3. By our previous discussion, it follows that a also has a maximum value at b equals p over 3. Substituting into our perimeter equation, we have 2 times s plus p over 3 equals p. So s is equal to p over 3. But then it follows that s is equal to b. Since s is equal to b, all three sides are the same, and it follows that our triangle is an equilateral triangle.